Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God's willing, in this tutorial, I'm going to show you how to perform two-way analysis of variance, also known as two-way Anova in Ibm Spss statistics. So I have a data set here I'm working on. So quickly, permit me to split my screen into two. So I'll show you the data set I'm working on. So I'm going to split it by minimizing and splitting it into two. So this is the data set I'm working on, hypothetical. We have an output recorded across 7 days of the week in different towns A, B, and C. Okay, so the whole aim of two-way analysis of variance is to see if there's a significant difference in this output here in terms of days of the week and at the same time the town. Okay, so quickly, just like in the case of one-way analysis of variance, we'll have to enter our data. So firstly, I'd like to define my variable. So I have a variable here called outcome. This is the outcome. Okay, it could be yields of crops, it could be teaching methods, it could be machines, it could be anything depending on what you're studying, but in this case I choose to call it outcome. Okay, so we have one variable called outcome, and the other we have what is called days, and we have what is called town. Okay, so quickly, for the days we have Mondays through Sunday, and we have for the town A through C, that's A to C. Okay, so quickly go to variable view here. So permit me to also maximize, so I would do it the right way. So my first variable is outcome, which is a dependent variable. So quickly, then I have what's called days, and I have town. Okay, so for the outcome, it's a scale variable. For the days is nominal, for the town is nominal. Okay, and for the outcome, you can call it outcome here. Then for the days, you can call it days of the week. And for the town, you can call it the town. Okay, then quickly, for the days of the week, remember we have Mondays through Sunday. Okay, so quickly I'm going to code it, but before coding, remember we don't have decimal points in our original data, so let me split the screen also to show you that. So no decimal points in our original data, right? And for the days, we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And Monday is the first, second, third, fourth, fifth, sixth, and seventh. Then we have towns A, 1, towns B, 2, and town C, 3. So quickly we can code it. Then here, permit me to maximize back to show you how to, and under days, come to values, define value 1 for what? Monday. Press enter. Value 2 for Tuesday. If you don't want to press enter, like I said, you can press add. Value 3 for Wednesday. Enter. Value 4 for Thursday. My bad. Thursday. Value 5 for Friday. Value 6 for Saturday. Value 7 for Sunday. Okay, press enter, and the next thing you need to do is verify. So I have the one for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Then you click OK. Okay, so we've entered that. Then for town, come to value labels 2. Under values, here the value labels 1 stands for, let's say, town A. Enter. Then 2 for town B. 3 for town C. Add, then click OK. We've entered our data, so you can come to data view to enter your data. So here I can expand it for readability's sake. Okay, so let me minimize by splitting the screen into two once more to go back, so we'll see our data set. So quickly, I'm going to enter the data. Remember, in the previous tutorials on one-way analysis of variance or one-way ANOVA, I said you can either enter the data row-wise, column-wise, or at random, but preferably and advisably, enter it row wise or column wise. So for the sake of these tutorials, I'm entering it row wise. Okay, so you know you can enter it either row wise or column wise. So row wise means I'm entering from town A. This is row 1. The scores, I have 35, 22, 29, 35, 21, 31, 40. Remember, all your entries will have to be in a single column. So quickly we're going to enter the data. So row wise here, I have 35, 22, 29, 35, 21, 31, 40. That's for row 1, which is row A. So permit me to write it down. I have 35, 22. Now I'm entering it 29, 35, 21, 31, 40. Right? Then for row 2 here, which is for method B, I have 29, 31, 28, 17, 26, 32, 16. So permit me to type this. I have 29, 31, 28, 17, 26, 32, 16. Then the last but one row, which is row C, which is row 3, I have 17, 35, 40, 27, 24, 36, 15. So quickly I have 17, 35, 40, 27, 24, 36, and 15. So observe here, I have 21 observations. Yes, that is corresponding with this matrix here. I have 7 columns and 3 rows, and 3 times 7 is equal to 21. So that's correct. But it will be ideal for you to verify your data before you proceed. So now let's verify it row wise, so we won't make any mistake. So we trying to minimize error. Okay, so we have 3522 verify here for row 1, 3522 29 35 21 31 40. Row 1 is correct. Then for row 2 here, we should verify also. It begins with 29 31 28 17 26 32 16, all corresponding. For row 3, which is C, here we have 1735, yes, 40 27 24 36 and 15. This is done so as to minimize errors. We don't want to have errors in our analysis. We try as much as possible to be accurate. Okay, then quickly here under days, we go back to our days here. Under days, we entered our data row wise, right? Meaning, since we entered it row wise, meaning 35 here appears under Monday, and Monday is 1, 22 is Tuesday, 2, 29 is Wednesday, 3. So if you observe, the pattern will be 1, 2, 3, 4, 5, 6, 7. So permit me, this is 1, 2, 3, 4, 5, 6, 7, right? Then the next one is 29, and this 29 is for Monday, so it's still 1, 2, 3, 4, 5, 6, 7. So you can actually copy paste, but I advise students not to, because sometimes there could be incomplete, okay, data. So I have 1, 2, 3, 4, 5, 6, 7. Then the last but one for the rows is row 3. And in this case here, we have 17, 35, 40, and 17 appears under Monday, which is 1, 2, 3, 4, 5, 6, 7 also. So it means here I have 1, 2, 3, 4, 5, 6, 7. Okay, then the next one I have is under the towns. Go back here, up for towns. I entered it row wise, right? It means 35 is for town A, 22 for town A, all through 40 town A, and town A is 1. It means I'll have 1, 1, 1, 1, 1, 1, 1 in 7 places. So it means here I have 1, 1, 1, 1, 1, 1, 1 in 7 places, right? Then the next score here is 29, which is our outcome, and 29 falls under B. And B is row 2, so it means from 29 down to 16 we have 2, 2, 2, 2, 2, 2, 2, 7 times, right? So meaning I have 2, 2, 2, 2, 2, 2, 2. Is that right? So, and the next one we have is 17, and 17 appears under row C, which is row 3. And since we are on the towns, it means we have 3, 3, 3, 3, 3 in 7 places. So I have 3, 3, 3, 3, 3, 3, 3, right? You can easily verify your data also to make it clean, okay? Because it's better to clean your data before performing any statistical analysis. So like we said, we expect this column here to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and we expect this to be 1, 1, 1, 1, 1, 1, 1 in 7 places, 2, 2, 2, 2, 2 in 7 places, 3, 3, 3 in 7 places. So let's verify. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is clean. Then the next one is town. I have 1, 1, 1, 1, 1, 1, 1, 7 places. 1, 2, 3, 4, 5, 6, 7, 7 places. 1, 2, 3, 4, 5, 6, 7, 7 places. So our data is clean. So all we have to do is permit me to maximize, so I'll perform the analysis. You see it clearly, okay? So to perform two-way analysis of variance, all you have to do is go to analyze, then come to general linear model, click on univariate, okay? Select it. Then for the dependent variable, it's going to be our outcome. You click it. And for the fixed factors, in this case, we have days of the week and town, okay? You can select them at the same time by selecting your Command A for Mac users or Control A for PC users at the same time. Can you see it? You can do that. Let me return it back. You can also do it individually, okay? Hope you understand that. And you can also use your Command click, okay, or Control click depending on the machine you are using. So if you are using Mac, you can use Command click, press your command and click on town. You see it has selected it. Or if you are using PC, you can press your control key and click on town to select, because sometimes you might have so many variables that you just want to select some few or a portion, okay? So now I'm going to send it to fixed factors. Send it. So all you have to do is click OK, okay? Sometimes there are some things you can actually do or reduce. Let me show you how to first before I show you that. So click on OK. Observe, this is our test of between subject effect. So this is our two-way analysis of variance, and we have our corrected model, we have our intercept, we have our days, the sources of variation due to days, and we have town. This is the interaction, okay, for the two, okay? This is error, this is total, this is the two-way analysis of variance. But let's assume you don't want the intercept and probably you don't want interactions, right? So all you have to do is you go to analyze, you come to the general linear model, univariate, okay, and you come to model here, okay, come to model. All you have to do is, it's not going to be full factorial, it's going to be build terms, because you're trying to build your own terms. So you click on build terms. Now if you don't need interactions, you select it. Maybe you can just say main effects. You just want to calculate for main effects, okay? So main days and town, on the assumptions you don't need interactions. If you don't need interactions, you just want to get the main effects, you click. If you don't want the intercept, all you have to do is click the checkbox here to uncheck it, okay? So the next thing you need to do is you click on continue, then click on OK. Observe, it has reduced it. Now we have days, towns, and error, right? If you check, the town is 82.952 and town here is 82.952. Also days is 260.476 and days here is 260.476. It does not change anything about the source of variation. It only eliminates or reduces those things you don't want in your analysis.